Kids, in 3.2, very much like 3.1, we're going to be graphing some quadratics again today, kids. Notice the ax squared right here. Doesn't that appear to be the same right here? The ax squared all kind of appears the same, doesn't it? But the thing that's different is a what here, kids? The thing that's different is what from yesterday? Yeah, the plus c right here. Okay, so that part right here is what's going to be new for you today. All right, so the plus c is new today. And we want to ask ourselves this question today about the quadratics that we're working with. How does the value of c affect the graph of f of x equal ax squared plus c? All right, we want to know what does that c value do to our graphs of quadratics when we apply it. So we're going to explore that today. So the goals that we need to accomplish today are this. We're going to be graphing some quadratic functions of the form f of x equals ax squared plus c. We're going to look at that mostly in decimals today. And then we're going to solve some real-life problems involving the form f of x equals ax squared plus c right here. Okay? So let's establish some vocabulary here first, like usual. It's a zero of a function. Anybody want to volunteer to read that for me this morning? I've got it. Zero of a function is an x value for a function that makes f of x equal to what, kids? Zero. Also, it's the what? Okay, let me just ask you this right here. Suppose I had this, suppose I had a function, 2x plus 6. If I wanted the zero of this, 2x plus 6 would have to equal what, kids? 6. Well, it would have to equal, if I want the zero, I want to set that function equal to what? 0. If I solve this, what would make this equal to 0, kids? Negative how much? 3. Yeah, if we solve this, so the 0 here would be x equals negative 3. So a 0 just simply means solve the equation. All right? Now, guys, if I had a graph, graphically, whoa, that's not a good graph. Let's just draw a quadratic through this right here. Kids, if you had a quadratic that was graphed like this, and they would ask you, what are the zeros from a graph right here? Well, the zeros would simply be the x values where they cross the x-axis. Those points are considered zeros. Okay, so you're looking at the points where they cross which axis, kids, if they want the roots or the zeros? The x-axis. Okay. You guys okay with that? That's pretty simple, isn't it? Okay, so visually, does that make sense of what a zero is? All right, so let's talk more. Transformation. It's a transformation that slides an original figure up, down, left, or what? Right. Up, down, left, or right. Okay. Basically, the word you just need to know is slide. Okay? Slide. Just taking a shape and sliding it left or right, up or down. Okay? We've talked about translations before, so you should be good with that. Okay, core concept right here. Let's talk about graphing ax squared plus c. In fact, let's pick a general function. How about we pick, let's pick, I don't know. Let's pick f of x equal, how about we pick 2x squared plus c. I'll squeeze it in up there. That's what we're going to work with, okay? 2x squared plus a c value. Okay, let's talk about what that c value does today, kids. All right, first condition says if c is what, kids? So if c is greater than 0, that means we've got a plus c on the end, don't we? Like plus 6. You agree with that? Okay, so we're talking about this right here. What happens when... Well, let's just go in here and get into decimals, and let's go and say, all right, suppose I have the function 2x, what did I say, 2x squared plus c? I'm going to type in 2x squared.
Attention all staff and students. We will start with the bus evacuation drills for freshmen. We'll have all freshmen report out the main entrance of the high school for the bus evacuation drill. All freshmen. Please report out of the main entrance of the high.
Okay, guys, we were talking about right here in the notes, what does a C value do if C is greater than what? 0. In other words, C is a positive value. All right, so if I go back in here to decimals right here, we've typed in 2x squared plus C up here. I'll put this slider in here. Watch what happens to my graph if I start moving my slider to be bigger than 0. What direction does this move?
Up.
It starts moving up. So like right here, guys, where's the vertex at originally in this problem? Right there. 0, 0. If I move this up 3 units, whoops, not 2.7, but come on, 3 units. Where's my vertex move to now? 0, comma 3 right there, right? Would you agree with that? So the vertex would be at 0, comma 3. So guys, when C is positive like this, or more than 0 right here, what's that C value on the end do to our original quadratic right here? Shifts it what direction? We say that that really translates it up. Now what if C is negative, kids? What if C is like a -3? What direction? Okay, here it was originally. If C is negative, what direction does it start translating my parabola? Down. Okay. So let's get into our core concept. Once we know that and can see that, it's like, okay, if C is greater than 0, this, whoops, if C is greater than 0, this, oh, let's pick a fun color today. What the heck? All right, let's go with it. All right, so if C is greater than 0, it translates. And when I say translate, that means slide. Translates up C units. Translates up C units. Now when C is less than 0, what direction does it move, kids?
Down.
Translates down
C units.
C units, right? Okay. So kids, I'm not necessarily going to get into the graphing part like we did yesterday. Remember how we were plotting points to get our parabolas yesterday? Remember doing that? We talked about vertical stretch or vertical shrink. Guys, I just want to talk about what's going to happen right here. So example right here. You tell me, kids. It says, graph these two functions right here. First of all, the x squared match. What part is different here, kids? The minus what? 4. Let me ask this. When I say compare the graph of f of x to x squared right here, let's talk about this right here. Guys, the x squareds are a match, aren't they? Okay. What would I have to do to x squared to make it match x squared minus 4? In other words, what's that minus 4 going to do? Translate it down 4 units. So here's the deal. To get from the function x squared to x squared minus 4, you would have to translate x squared down how much? Why down, kids? Because it's a negative C out there, yep. Guys, that's pretty easy, isn't it? What if there was a plus 22 out there on the end instead of negative 4?
You have to translate up
You would have to move x squared up. How many units?
22.
22. Very good, D. All right, guys. So when we see it in decimals, does it make sense to you guys? When you see it in decimals, does that make sense to y'all? Okay. I'm going to wait till I know everybody's got that down. Do you have questions so far about what that C value does to our original quadratics at all? So give me a show of hands if you're ready to move on to the second page. Are we good here? Oh, I'll wait for you, Sam. You yell at me when you're ready, buddy. Okay, here we go. So page 2, kids, let's talk right here. So let's talk about this right here. I'm really kind of concerned about just really saying graph 2x squared plus 4. I don't really need to do this, kids, because I think we know the characteristics already, but it says, I'll put it in decimals. It says compare the graph to the original graph. This is the most basic function right here, right? So guys, what we're really kind of starting with here, in this case, is we start with x squared. So I start with the most basic function, x squared, and we're going to go
Attention
to
all staff and students, we need all juniors to report out the main entrance of the high school for bus evacuation drill.
Okay, so
All
let's have that
juniors,
now. I'll
please
pause
report out
this.
the main entrance for the bus evacuation.
In this example right here, we're trying to say, compare the graphs right here. Now guys, when we talk about, what's the most basic quadratic function that there is? What's the most basic one? X squared. Now guys, just, if I wanted to visualize this, I'm going to jump in here and talk about what's going on. And you guys, I think you know the answer to this already, but guys, what's this positive 2 out in front going to do to the original function? It's going to make a vertical stretch. It's going to pull the points away from the x-axis by a factor of 2, or multiple of 2, I should say. And then, what's this plus 4 going to do now? Up 4. So let's just look at this real quickly. If I say, all right, x squared is my function right here to start with. This is the most basic one. I'll type that in. All right, there's x squared. Now, guys, if I put in 2x squared, doesn't that appear to take this point right here, which is at basically 1, 1? How far above the x-axis is this point right here? 1 unit, right? And now that 1 unit above the x-axis on this vertical line has been stretched up to what value? 2. So there's a stretch. What's the plus 4 now going to do? Now it's going to take what that 2x squared is, that vertical stretch, and then shift it up how many units? There it is. Okay. So a couple things that happen here, guys, is this. There's a vertical stretch that goes on. Okay, so we see a vertical stretch. So I'm going to say 2x squared plus 4 is a vertical, did you guys say stretch? By what value?
2.
Followed by a, here's the word I'll use. What's this mean right here? What's that word translation mean? Yeah, we slide it up, right? Followed by a translation. How many units up, kids? 4 units up. Followed by a translation, 4 units up. Now I'm going to go back to my graph here in a second. Once I know you have that down, I just want to talk characteristics real quickly. Okay, real quickly, kids. Characteristics of the graph here, if I look at this. Could you identify the vertex of both graphs? Would you be able to identify the vertex of both graphs? Yes. Would you be able to identify where the line of symmetry is? Yes. What is the line of symmetry? X equals what value here? 0. Okay, x equals 0 right there. All right? So I think that once you see the graphs, after you move them or position them, they're going to ask you, okay, after you've moved this, where is the vertex now? Or where is the line of symmetry? They're going to start asking stuff like that. So here's what I need then to do. We need to take these ideas of transformations and apply them down here. First things first, you guys have everything written down there for example 2? Okay, let's talk example 3. This is kind of an important one right here. I like this one. Okay. Translating the graph of y equals ax squared plus c. First of all, it says let f of x be what function, kids? Negative 0.75x squared plus 1. And then g of x is that original f of x function minus how much here? 3. Okay, it says describe the transformation from the graph of the f to the graph of g. Well, guys, f was this whole function right here. It's basically saying take this function f and do what, kids? subtract what? 3. So when it says, describe the transformation, what's this minus 3 going to do to this original function here? What's a minus 3 on the end going to do to our function? That's like our plus c on the end. Yeah, it's going to move it down 3 units. So that f of x minus 3 is the same as taking your function f up or down, kids? F of x minus 3 is the same as taking your original function f and moving it down 3 units. Okay? So f of x minus 3 is the same as moving that f of x function down 3 units. So let's get this, kids. First of all, the part that I'm interested in seeing what happens right here is writing an equation that represents g in terms of what? Okay. Guys, right here, they say g of x is equal to f of x minus what? Isn't that what they tell us right here? Okay, but guys, what is f of x? What is the function f of x right here? Negative 0.75x squared plus what? 1. So g of x would be that function f of x at negative 0.75x squared minus 1. But that's the f part. But what's on the end out here now, kids? Oh, I think that should be plus 1, shouldn't it? Okay. If I want to write a function for g of x, we're taking the original function f, negative 0.75x squared plus 1, and subtracting how much from it, kids? So subtract 3. Guys, what I've written up there, wouldn't 1 minus 3 combine to be negative 2 up there? So the function g of x has to equal negative 0.75x squared minus how much? 2. The 1 minus the 3 would be a 2. And let's just check, okay? Let's just see what's going on here. They told you guys that f of x was what function again? They told you f of x was what function again? Okay, so let me go ahead and punch that in here. Negative 0.75. Was it plus 1? Okay, there's that function. In green, let me go home. There's that. We think that g of x should be negative 0.75x squared minus how much, kids? 2. Okay. Does it look like from the green graph to the black graph right here that we went down 3 units? Well, what's the vertex right up here? What's the vertex, kids, on the original? And then the new function we wanted to subtract 3 from, what's the distance between 1 and negative 2? 3. Isn't that what we wanted to do, was shift that down 3 units?
Yes.
So do you understand why this is the new function right here that's been shifted down 3 units? Guys, couldn't have I just taken this plus 1 on the end and subtracted 3 right off the bat to get that? Because that's what that minus 3 would combine with as a plus 1, right? Okay. All right, good. Well, moving on then. Moving on. Very good. Any questions to this point? Okay, cool. Well, here we go then. Let's get into example 4. Example 4 is all about finding zeros of a function. Okay, let me get you a good example for this right here. We're going to look at this algebraically and we're going to look at this graphically. But you're going to be given some functions like the following. Like maybe say, oh, I don't know. How about, okay. Are you ready for this? You can lie to me and say yes.
Yeah.
You're going to get an equation like this that says y equals x squared minus 36. Okay? And in here, right here, kids are saying find your what? They want to know what value of x is going to make this a 0. So what you're really doing is replacing y with what? You're going to say, okay, well, if I want that function x squared minus 36 to find zeros for that, we have to set x squared minus 36 equal to 0. Now, guys, I could go back to a factoring, and we could do it that way. Or I can make this somewhat easy for you. What would you like me to do? Okay, here's what I could do. To solve for x, we'd have to get x squared alone first. All right? And in this case right here, what I could actually do is add 36 to both sides. So when I add 36 to both sides, kids, I've got 36 is equal to what value here? X squared, right? You guys cool with that? All right. Well, how do you undo squaring? What operation is going to undo squaring to get x alone? Square root. Now keep in mind, square roots can either be positive or they can be what? Negative. So right here I can say, well, x would equal either positive 6 or what? Or what else? Okay. 6 or negative 6. Now let me show you something graphically about this. We said zeros are also the points where a graph would cross which axis? The x-axis. So if I went into decimals to say, oh, by the way, let me just punch this in right here. What was my function? X squared minus 36? Was that right? What's this x value at that point? What's this x value? Works, doesn't it? Okay. All right, let's try another one. What if I get into something like this? What if I say, oops, I don't want that. What if I have y equals, not even an x in there. I'll throw a t at you. All right, never mind. You guys aren't awake. It's okay. The bus evacuation must have taken it out of you. What am I looking for here again, kids? Looking for t, but we want the zeros of this. So what do I have to set equal to 0, kids? Set y equal to 0. Let's try this. Let's try and get t squared alone first. What would I have to add to both sides, kids?
3.
Add 3. So I've got 3 is equal to 12 t to the second. Now if I want to get t squared alone before I solve for t, kiddos, what do I have to divide both sides by? Now guys, help me out here. 3 over 12. Let's just leave this in fraction form. Can 3 over 12 reduce?
Yes.
To what?
1/4.
So do you guys buy that we have 1/4 equals t squared? Anybody know the square root of 1/4 when we get to this step? What's the square root of 1 up top? What's the square root of 4 on the bottom? So t could either be plus or minus 1/2, couldn't it? Now again, if you weren't sure on the algebra part of this right here, solving this algebraically, where could you go? Could go to decimals. Let's just confirm this real quickly. I'm going to end with this example. We'll pick this last one up tomorrow. What was the function again? I'm going to use x in there. Was it y equals, was it 12t squared minus 3? So I'll just put in 12x squared minus 3. Check your zeros here and here. What are those values, kids? -1/2 and +1/2. Does that match what we got algebraically?
Yes.
Okay, do you make the connection there?
Yes.
All right. Hey, I think that's a good place to stop today. We'll pick up that last